that we don't have the 6 figures, like text, images is solved pretty much, and it's very hard to tell apart, like, photos being generated like with context. Video, I think we're still on the way. I would love to hear from the panel here. World models, of course, feels like we're still in early innings. I just want to maybe hear from the panelists to give us sort of a roadmap and how you see generative media models. What are we still lacking as far as capabilities, and where do you think we'll see more breakthroughs in the coming years? Maybe I'll start from Ben.
Sure. Thanks, Jennifer. Yeah, I mean, I think going front to back, right to front here, you ended talking about world models and I guess 3D, and I think that that's something where, thinking about 2 years ago, we were just starting to see the very first combinations of image frame space diffusion with 3D reconstruction, and since then we've seen huge advances in 3D diffusion for object modeling, obviously sort of real-time action-driven world models in frame space, and the kind of hybrid combination of best of both worlds, and it's still super early. I think we're still incredibly early on the 3D side for sure. On the research side, there's still fundamental representational questions, right? 2 years ago, again, we also basically switched over everything in 3D to Gaussian splatting since then. That can happen again. I think the kind of confluence of how explicit representations will balance out with frame space ones. We're seeing a lot of people do things around spatial memory, conditioning video models with cameras, with points, with all other types of 3D grounded information. And that is still, I think, basically anyone's game to figure out what the final form of that's going to be, or whether it's going to be a kind of spectrum of different models targeting different use cases. So still early, I would say, on the world model side for sure.
Yeah, I think what will be paramount in the next years is to give people additional means to control the output. This is, I think we always thought this when thinking about stable diffusion or text image models in general, what they unlocked was just a very intuitive means to interact with them. And we saw the same for editing models. When we released Max Context, it was the first model to actually be able to, in a scalable way, edit images. So there was another level of control because people could prompt not only with the text, which back in the days, which they were very used to since Stable Diffusion, they now can also prompt with images, and by that get this kind of nice image editing capability out. And I think whenever you add a new layer of control where people can just steer the result in a more precise way, this unlocks always a huge kind of new use cases that these models will be able to serve, and obviously that will lead to more and more adoption. And then obviously like going into all kinds of domains, combining image, video, audio, and then also like this kind of state that then needs to work on, right? I think that's also obviously on a more fundamental research side a super important topic, especially when we talk about like, I think at this point everything is doing latent generative modeling. How should this representation, I think that's also what we talk about then. Like this is an open question, it's exciting to think about it, I think, and we'll see a lot of interesting stuff I think in the next few years.
Definitely.
I think even the image problem is still not solved. Like there are like 95% for image, for video you might get 80%, for audio you might get like 97%, but every single like iterative improvement there is like as hard as like going from 0 to 97%, right? And that's what we noticed, like the amount of frequency on image models is like the amount of release on image models is getting accelerated, like another one flux context when the new capabilities getting it right, like one step. Like flux context was not just the best text to text everything model, but it was also the best text to image model, like adding these new capabilities, new controls. That also improves like the base model. So we feel like there's still a decent way to go from there. For video world, like I think as Jennifer said, we're too early. Like we just recently noticed that without sound, all the videos are very boring. Like there's no use case for it. There's like it feels like a good gimmick, but like with just like now the sound effects and like text to speech within the video, it feels great. And world models, we just started.
To focus on voice, I appreciate Jennifer saying at the top that we got to the Uncanny Valley first. Jennifer's one of ElevenLabs board members, so when she asked me to come to this, I obviously had to say yes. But she also played a very critical role in getting us almost there. I think we might be a little farther along with voice than some of the other modalities, but there's still room to improve. Hyper-focused on perfect emotion, perfect intonation, perfect prosody. And we believe that people can tell the difference between a voice they feel is truly sounding human and one that's almost there. So I think there's still room to grow there. And for ElevenLabs, the company, given that we do feel we're close, one, we're trying to take it to the absolute max, but in the meantime, develop amazing products on top of foundational models that give our users and our customers what they want, and that keep them with us, even we do get to a point in the not distant future or the distant future where our research really diminishes and we all kind of hit a ceiling. So I feel there's like a dual focus for frontier model companies like us. We're also building products. It's getting all the way to the very top and building amazing products along the way.
And what I've always been impressed by in your voice, image, video, like all of the models, is such a long tail problem. Like you're either trying to model sort of how humans speak and use their voice, or trying to model the world. Like it is a very complex, very long tail problem that might get close to like the 95, 98%, but will never be like 100%, just given how complex the form is. Which leads to my next question of just like thinking about pushing a lot of these models into production. Like a lot of you guys are working on the frontier research. Like what are some of the capabilities, infrastructure, whether it's scaling, whether it's like inference, whether it's the safety and the guardrails that's still needed to take the research into the next level? I'd love to hear about that. Whoever wants to start first.
I can go. I think that there's challenges on the system side of things. As the models get larger, you need more compute. But when you put more compute, the models are going to get more expensive because GPUs are very expensive. And when you make it more expensive, the demand gets lower. So you need to create a careful balance. The amount of systems work and inference work that we started doing got like 10x higher after the release of Flux, which was like 5x, 6x bigger than like SPXL in terms of raw size. And like the video models are just like 10, 20, 50x more compute intensive than image models. So there's definitely the systems aspect of these models. As you add more capabilities, as you add more controls. Like Flux context is twice more expensive than generative text image model because you need also that time to the image. So working on within these constraints, I think that there's definitely systems challenges that we need to handle.
And to add to this, I think other than or opposed to the language space, we are still very early in scaling out these models because the data dimensionality is so much larger there, right? That's just an inherent challenge in terms of memory. So the scaling of the models didn't keep up with the scaling of language models. So we're just starting to get them really scaled out. That's on the infra side that will obviously lead to more challenging demands, especially once there's a strong desire to go really in real time. That's also what we're still lacking, right? We want everyone to have a real time model. But having growing larger and larger models that should similar or simultaneously be faster and faster is actually quite a challenging situation, but yeah, I'm sure we will get there.
Yeah, I echo that point so much because I also work with a company called Mutz, that's the API for video, where we take a lot of what we watch from YouTube or we watch on our phone for granted, but be able to upload video, long form video in a fast, time efficient manner, and be able to stream it down as the user generated content is being uploaded. There's just huge infrastructure work behind the back as we're going to the generative media maximum.
It's again compression. I think compression is at the key of so many things that we don't even notice when we don't think about them specifically diffusion or generated moments in the end. Also the lossy compression that you apply on top before you actually train the model.
Right. Talking about which, I want to ask Ben this question since you just launched the RTFM this week, I think? Yeah. It is generating video in the real time as you're interacting with it. It's a super cool demo. If you haven't checked it out, please do. I want to ask first, how is this model being done? I guess reveal some of the secret sauce, and also what it means for developers as well as creators.
Yeah, so we launched this very early kind of technical demo of RTFM, a real-time frame model, about a week ago now. And it really is just a small research proof of concept for the most part. It's streaming around, if I remember right, I think 512 by 512, hitting around maybe like 20, 30 FPS, live frames off of cloud GPUs. And we kind of took this intermediate stance here. So I think as a world model company thinking about spatial understanding, spatial intelligence in 3D, we definitely consider rendering and graphics and the future of graphics to be a core part of kind of our mandate to explore. And obviously with the progress that's been made in video, it's totally impossible to ignore the potential of having an almost entirely learned renderer. And that leaves a lot of questions as to what is kind of most deeply fundamental in terms of the level of input and control into a model that you want to drive real-time output frames. So for this, we kind of took this as a almost alternative to our mainline current beta product, Marble, that outputs Gaussian splats, renders those client side. We wanted to explore what would it look like if we actually had kind of a different renderer head that could simulate a much wider, learned, rich variety of physical phenomena, but have the limitation that is being streamed from a GPU in the cloud. I'm very excited to see things like, reflections, lens flare, beginnings of ambient dynamics, things that you take for granted from video models, but with that level of immediate, relatively low latency and precise control coming from inputting an exact camera pose and kind of keying off of anchor frames nearby. So we found that to be a very complementary approach to explore, along with our kind of mainline current one that we're planning to offer. And we definitely are planning to stay on top of this, scale this, explore this, because we do know that this is very likely a big part of the future. I mean, we already see DLSS and learn methods making their way into very mainline kind of graphics pipelines, and I think that's going to just expand more and more towards the kind of fully learned approach over time.
Do you think we're pretty close to a point where we can generate these models on the fly and interact and play with it at the same time, like a game simulation engine?
I mean, I think to kind of everyone's point before, this is a huge inference scaling question and also a fundamental model question too, right? We have neither scaled up to the maximum here, right? We've seen GD3 probably the high watermark in this space, but incurring massive computational demands almost certainly, and that has even farther to push before even those videos, right? They only go for 30, 60 seconds, like a kind of relatively small environment. It's nothing compared to a modern, well-crafted AAA game in an open world. So I think it's going to be a pretty big scaling push to get to that in many, many dimensions. But also a very exciting one, and progress is super fast, of course. So we'll see kind of how things go over the next few years.
For sure. And I want to ask a question to Andy, just given that you have seen the arc and the journey with image and video models, that we have, be able to scale somewhat at this point to, be able to generate and also deliver the artifacts to the majority of the end users. And you have done a tremendous amount of open source work from Stable Diffusion to, Flux and Context now. How did the landscape change over the last few years on, the open source landscape with that, and where do you think, what we still need to push for the frontier that you want to call for action from the open source community?
Yeah, so I think, when I look back in the data, into the days of Stable Diffusion, it's like, it's actually insane how much more professional all the use cases got that are also built in the open source space. I think we see this with any technology, right? Once it matures, it enters new use cases, and that then leads to professionalization of everything. And I mean, I showed a couple of really old samples in my talk earlier. It's actually, if I look at them now, I'm like, oh.
But they were magical at the time.
Yes,
always saw those samples.
I know exactly how I felt that. It was crazy, and now I look at them and I'm like, this doesn't look as accurate or as good as as it was in my memory, right? So it's everything gets a lot better also in the open source space. The landscape shifts away from I think specific fine-tunes for things like character consistency, because with editing models we don't need that anymore. Maybe for very, very high quality use cases, but I think this will also change more. But yeah, I think it's very important to always have an open ear to the ecosystem, because they are always a very good, it's first of all fun to see what people creativity and intelligence of the crowd in a way. It's super nice to see this, but it's also a very good predictor into the future. What is actually interesting? What is an interesting problem to work on and to solve? Because obviously we have a lot of things in mind, but we cannot like think about everything. So looking into the ecosystem in terms of use cases is actually very helpful. And in terms of use cases, we've seen like more and more fine-tuned targeting and very specific professional business problems.
Yeah, maybe in 2 years when we look back on all the Pokemon videos generated by Sora, we'll be like, what were we doing back then?
Absolutely, there's some videos.
And I'm curious how have this like open source strong roots either benefited you, I guess as founder of BFL, or disadvantaged you in some sense of like having to tailor and view for a broader audience, not just like, let's say, specifically for just the creators that are building graphics.
Yeah, so I think, as I said already, this like kind of flywheel that you kick off when you release something open source and you see what they're building and then you take something back. Because, yeah, as a team of even 1,000 developers or something, you can never build as fast and be as creative as like the entire crowd in a way, right? So that's always something that I think open source businesses benefit from. And yeah, I think it's just also about not only creatives, if you think about enterprises, really established enterprises that may not be like AI native, they most often have the strictest privacy requirements, and they don't, by no means, they want to go with an API. They want to host either in the cloud or on-prem. They want to host their models.
Right.
If we have an open source model where the code is available, the model is available, they can test this, they can play with it, maybe they may require help, but the entry part for self-hosting is so much lower compared to closed models, so you also have a much better vehicle into like enterprise use cases, because they know your model, or they have the chance to look at it, other than for a closed model where they never can look at, and then you enter into a licensing agreement with them or something, and then that's actually the first time they see this model. This obviously has a much higher entry barrier, right? So that's another thing. It's not only creatives and this kind of community aspect, it's also a real world, or like a real argument for people who want to do self-hosting. Hey, look, you can just look at it every day, you can play around with it for 3 months, 6 months, until you feel comfortable with it, and then come to us and buy a commercial license for this, right? So this is another part of it, also commercially very interesting, definitely.
Yeah, with open source, basically the credibility hurdle you already crossed as you're going to enterprise.
Yeah.
But then, it's about proving out other things. That makes sense. And Batuhan, I would love to ask, well, first, given like everybody at the panel are sort of partners or users of Fal, and you're head of engineering there, how do you think about which models or modalities to support and how to support them on the Fal platform?
From the start, we were like, okay, this language marketplace and media marketplace are completely different personas, and we want to just focus on like one buyer, because it seemed like crazy to build a company where you have two distinct groups of users. Maybe at a larger scale this might change, but right now I think like our primary buyer has been buying images when we first started. Our customers are the developers that were working. Now they're starting to adopt video, they're adopting image, they're adopting audio, they're adopting 3D. So I think like the main distinct point for us is this something that's useful to our customers? Is our general customer base is going to enjoy using this? And any sort of thing that's touching media is a good one. Within that, there's so many different distinctions that we make, especially on the open source front, where there's countless models. If you go to Hugging Face, you're going to see hundreds of thousands of models. 99% of them are fine-tuned, or like under versions of it, but some of those are like real models. And for us, it needs to fill a unique gap. We feel like even the older models, if they have a certain personality, they have a certain thing that they excel at, is useful. So we essentially build the infrastructure to handle these like low traffic models really, really well, as well as like high traffic scenarios where we go ahead and optimize those models and serve them. In terms of partnerships, we want to partner with anyone who's like essentially filling a gap in industry, whether it is the image models or upscaling or background removal, we're pretty much open to everything.
And we were talking about the challenges of like being able to take the delivery of the models to the next level and maybe enabling the dreams of being more real time, whether it's video or models. How are you thinking of, I guess, architecting or solving the problem from the platform?
Our real-time journey started as speech-to-speech because this happened before real-time image or video models, where we actually architected our entire system around, let's make sure our overhead of like this distributed supercomputing infrastructure, scheduler, and everything else is less than 50 ms. And let's make sure we can stream both inputs and outputs bidirectionally at any point in time. I think that really helped us, like the speech-to-speech wave that didn't actually happen a year ago. That really prepped us for like the upcoming generation of like real-time video models. You know, whether it be from Descartes, whether it be from ElevenLabs or PFL, and like whatever that might come up with. So I think we spent quite a bit of infrastructure effort to perfect what we have for real-time video models.
Very cool. And I'd love to ask Alex this, given that ElevenLabs has a very, very extensive I guess product line, including speech to text, text to speech, sound effects, now the music models, like we're working with basically creators, developers, enterprises across the world and across the globe. I'd love to hear about some of the interesting, I guess, both use cases and the challenges as you're expanding more globally and solving sort of this long tail voice problem.
Yeah, absolutely. So I mean, one challenge is sort of what you just laid out, which is we're doing all these different things for all these different customers, and we as a company need to figure out how to keep doing them all or where we want to focus. As Andy said, like you got to look in the ecosystem at the use cases, and a lot of times we let our users and our customers tell us where we should focus. So gaming, for example, is a place that we see a lot of room to run. We work with Epic Games to power the voice of Darth Vader in Fortnite that users can interact with. Like gaming is one of these spaces where our tools, whether it's music, whether it's voice, whether it's agents, sound effects, can be used to create a like non-interactive game experience, but where companies like us and all these companies up here are able to add like brand new value that hasn't existed before. It's these immersive, interactive experiences, many of which exist in gaming, that we see a lot of room to run in. Dubbing, like our company was originally founded by two Polish kids who grew up with, was founded by two Polish kids who grew up with really bad dubbing in Poland. One man who did the voice of every character, male or female, in every movie, every TV show. And we're still working really hard on that to fulfill the mission of making all content, all audio content, all television, film content available to anybody in any language with the original voice and intonation. So we see a lot of room there. And the possibilities really are endless. Those are more media and entertainment focused. Of course, with agents, we're doing a lot of work in the customer support space, where voice is really critical, but they're also using music for background music, for ads. We're following our enterprises as they find the use cases for our tools.
Makes sense. And you have navigated some of the very challenging, I guess, situations where I think for largely the developer ecosystem, we're very welcoming for any new technology, but with creatives, with labels, like with, I guess, places that are not as open as sort of the US market, there are some really, I guess, complex and gnarly situations you have to navigate. Is there any stories you want to share from that?
Yeah, I mean, I can talk a little bit about music. So for our music model, which we released at the beginning of August, we decided to work with labels, work with artists to put that model out. That required really hard negotiations over rights with partners like Merlin and Cobalt, or two enormous players in the music industry, in order to get the data needed to put that model out. And I think one of ElevenLabs' superpower, and you can accuse me of drinking the Kool-Aid too hard, is our research talent is off the charts. They're able to do more with less. And so as somebody who's doing legal and policy at the company, it's my job to enable them. And for music, it was going out skills done, so we could put out our first model and continue to do more and more and more write skills with artists and with labels, with publishers, so we can keep improving that model.
Very cool. And I guess a lot of people were in the beginning questioning if with like more limited data set, if you can still train a very capable and powerful model. I guess that's also a resolved problem.
Yeah, we hope we've proven it, but we know we've got a lot more to prove. So more to come for music for sure.
Yeah. So the panel originally was named diffusion models, but now it's talking about next frontier models because the line of diffusion model versus transformer models are very much blurred at this point. I'd love to just ask the panelists here, given you're in the deepest research and most kind of researching, looking to new model architecture and how it impacts sort of the creative workflow. Like, what do you think will be the next, I guess, set of challenges or opportunities while we're thinking about fusing the different architecture and approaches to bring the creativity to the next level?
I'm going to start this one. I think 3D is kind of a funny domain because diffusion has not even quite fully reached 3D yet, so there's a couple years behind it in that sense. So I think we will continue to see a lot of benefits from people figuring out the right, as Andreas said, the right latent representation to kind of bridge the full benefits of supervised diffusion learning with 3D modeling, especially at scale, not just a single object, but to full, rooms, environments, and worlds. So I expect there's a lot of space still left to play there because of the representational issues. I think maybe for other domains, maybe people keep moving forward, but for 3D, I expect a lot more still to come with existing architectures.
Yeah, I think it's super interesting so far, for what we're doing, we see two main probabilistic approaches competing with each other, and there's a lot of, I think everyone has their own opinion on like, is it all recursive models or is it diffusion models? Is it maybe something like transfusion that is a bit like in between? I think both model sides have drawbacks, and I think as researchers we should think about how to best maybe combine the strengths and of both sides. So for instance, if you look at diffusion models, they are super nice at inference time because I can just like reduce the steps. I can do this like step distillation where I bring down the number of steps from like 50 or something after training to as little as 4. That's an order of magnitude speed up, which is amazing. On the other hand, if you train diffusion models or flow models, whatever you want to call them, every data point that I'm training on is giving me infinitely many training examples because there's this trajectory from noise to data, and I can pick every step in between noise and data, which is it's a continuum in between, right? And get trained on that one. So that shows you how, like, from a data efficiency perspective, how inefficient the training is. At the same time, our regressive models are super efficient at training. I can do this parallel kind of train all tokens of a data point in parallel, super nice. But then at generation again, I have to generate every single token, and that's just like an inherent bottleneck. I can do funny things like speculative decoding and stuff, where I can maybe get rid of, like, it's a hack to basically get rid of this, but it's just like this iterative nature in the data, in the direction of the data is there, the limiting factor. So I think as researchers, we have to ask ourselves how we can combine the best of both worlds into maybe a new architecture. Personally, I love spending time thinking about it, and yeah, let's see what people come up with. But I think there is now needs to combine these two approaches into something more better in each dimension.
Yeah, and another comment I have on that is like we tend to think a lot of these models as disjointed modalities of like voice, 3D, image, video, but in reality, when like you're creating, I guess, artifact, that a lot of it is sort of intermixed. That you need text in video, you need text on image, and then video, you need voiceover on like a 3D painting of the world. Like a lot of these things need to be still fused. At this point, you're kind of disjointed, but over time, it will become more and more of a, I guess, mixed reality. Batuhan or Alex, do you have anything to add?
In general, right now, like at least at this point in time, like 99% of the models that we do are diffusion models. I think that's been the paradigm so far. There is a couple good exceptions, and there's upcoming upcoming, multi-model models like Generative 2.5, Flash, and others. I think we are still in the camp that we're still in the camp that diffusion models at certain extent are going to come for the next year or 2 years. With some, there might be other aspects, but we have been focusing on figuring out our systems around that.
Awesome. With that, we're at time. Let's give another round of applause to our